Hi everyone, I'm about to basically provide the solutions for the factored worksheet, the factoring worksheet, or really the quadratics worksheet where we're turning from standard form to factored form. All right, so let's start with number one. Okay, number one, the question was, let me just write it properly. It was f of x, let me go here, f of x is equal to x squared minus, oh sorry, it was plus 3x minus 18. And so part A basically said rearrange in standard form. So it's already in standard form, so f of x is equal to x squared plus 3x minus 18. B said write down the vertical stretch. So the vertical stretch right here is always in front of the leading coefficient. It's the highest term, but the term with the biggest degree is this one right here. So it's 1. So the vertical stretch is basically equal to 1. C is write down the y-intercept. As we know from the standard form, the constant term is basically the y-intercept. So the y-intercept here is negative 18. D, rearrange in factored form. So if we want to get this into factored form, we have to factor it. So we can use it do that using the man method. So let me just do that. So it's x squared plus 3x minus 18. So m is basically 1 times negative 18, so that's negative 18. The a is the addition, which is the middle term, so that's basically 3. And n is finding two terms, or two numbers that multiply to negative 18, because that's what the m stands for, and add 3. So the two numbers that I can think of are 6 and negative 3. 6 times negative 3 is negative 18. 6 plus 3 is 3. So the next thing we do is this middle term will split. So the 1x squared stays as is, and this will split into these two terms that we've determined here. So it'll become plus 6x minus 3x minus 18. And if I continue with this, I'm going to group the first two and group the last two. If I group the first two, I'll basically factor out x, and we get x plus 6. And if I factor these two out, negative 3 will factor out, and once again, it'll be x plus 6. And it's plus 6 because negative 3 times positive 6 is negative 18, and these two should be the same, and so once again, you can factor out x minus 3, because there's that, and then we're left with x plus 6. So the factored form of this is f of x is equal to x minus 3, x plus 6, and that's our basic factored form. Let's do E. E says find the x-intercepts. So in order to find the x-intercept, the y, or the f of x, must equal to 0. So in other words, 0 is equal to x minus 3, x plus 6. And whenever you have a situation like this, each of these factored terms can equal to 0. So x minus 3 equals 0, so x equals 3. So that's one x-intercept. And then for the second one, we can do the same thing. X minus 6 equals 0. So x equals negative 6, and that's the second x-intercept. Let's do F. F says find the coordinates of the vertex. So basically, as we described, that the x-coordinate of the vertex is halfway in between the x-intercepts. So the x-coordinate of the vertex, as we said, was p plus q divided by 2. And remember, p and q stand for the x-intercept. So in this case, it's 3 and negative 6. So it's 3 plus negative 6 divided by 2, which is equal to negative 3 over 2, which is equal to negative 1.5. So we got the x-intercept of the vertex. Now how do we get the y-intercept? Or sorry, how do we get the y-coordinate of the vertex? So if you look at the equation, here's the equation in factored form, which is x minus 3x plus 6. And f of x is basically, another way of writing f of x, is basically the y. So if we want to find the y, all we have to do is get our x-intercept and plug it in, or x-coordinate, and plug it in here for the x's, and then we can solve for y. So let's do that. So basically y, or maybe just we'll switch back to white. So y is equal to x minus 3, x plus 6, and I'm going to plug in, for x, I'm going to plug in negative 1.5. So it's going to be negative 1.5 minus 3, and it's going to be negative 1.5 plus 6. What do I get from that? That's going to be negative 4.5, and that's going to be positive 4.5, and that's equal to negative negative 20.25. So you can just plug that in and figure it out. So the vertex, the coordinates of the vertex are negative 1.5 and negative 20.25. And that's our solution for F. Let's go to G. G says find the equation of the axis of symmetry. So the equation for the axis of symmetry is really just the x coordinate of the vertex. So it's going to be x equals negative 1.5. H said to sketch the graph. So let me sketch the graph right here. So basically we have to use all the information that we found, all of this, you know, everything from A, B, C, D, all the way to G to help us sketch this graph. So let me sketch it right here. So here's our x, y plot, okay? Let me get a green color. So we know that our x-intercepts are negative 6 and 3. We know the axis of symmetry, which is negative 1.5, is basically halfway through, right? So that's negative 1.5, well, which is really just right there. We know that our, let me just actually just use white for a second here. We know that our y-intercept, is actually negative 18, and we know that the y-coordinate of the vertex is actually at negative 20.25. So really, what we have here is we know that this this parabola has to go through pretty much these red points as shown. So all I have to do now is just draw the parabola right here. Here's the vertex, which is at negative 1.5 and 20.25. It hits the y-intercept at negative 18, and then goes through the other x-intercept, and that's basically our graph. Now, the last one basically said, so find the other point. So the question basically said, find the other value of d such that f of d is equal to f of 2. So let me just draw that. Let me just get that. hi. So basically we want f of d is equal to f of 2. So we got to find what d is. So here's the thing. Let me just use it. So here is where 2 is, and f of 2 will be somewhere over here. I don't know what that point is. All we have to do is find the corresponding x point. So in other words, d is right here. We have to find that point, because basically what's happening is that this is the axis of symmetry. This is basically what divides the parabola into two. So in order to find this point, I need to know what this distance will be, right? So if this is negative 1.5, and let me just write that in green. So here's, or let me just write that in red, maybe, or a different color. Let's put blue. Oh no, maybe that's a little too hard to see. So I'll just put that in green, maybe just to make it easier. And that's D. So what we need to do, if it's an axis of symmetry, the distance from here to here should be the same distance from here to here, because it's symmetrical. If it's an axis of symmetry, then the distance to one end should be the same distance to the other end. So what is the distance from negative 1.5 to 2? Well, the distance here must be, if it's negative, so from 0 to 2 it's 2, from 0 to negative 1.5 it's 1.5, so the total distance must be 3.5. So the distance from here to here must also be 3.5. Now d is 3.5, a distance of 3.5 to the left of negative 1.5. Let me just show that up. It's to the left of negative 1.5. So if I put negative 1.5 and if I go 3.5, a distance of 3.5 to the left, then this point must be negative 5. So d is equal to negative 5. I hope that makes sense, because the distance from negative 5 to 1.5, well, that's a distance of 3.5. And the distance from negative 1.5 to 2, well, that's also a distance of 3.5. So therefore, d must be negative 5, because that's what I'm looking for. The value of d, where I get the same output, right, is going to be negative 5. So therefore, in this case, d is equal to negative 5. And that's our solution. All right, so let's move on to the next one, which is basically pretty much the same thing, but now for a different problem. So number 2 was x squared minus 7x plus 12. So x squared minus 7x plus 12. So A says rearrange it, and it's pretty much already rearranged, so we don't have to worry about that. So it's minus 7x plus 12.
B was to find the vertical stretch. The vertical stretch will be for the x squared term, so that's 1. So that's 1. C says find the y-intercept. That's going to be the constant term, so that's going to be 12. And that's the constant term right there. D said rearrange into factored form. So basically, this is x squared minus 7x plus 12. Ooh, plus 12. Let me just erase that a little bit. So it's plus 12. So we have to factor this. So once again, we have to use the man method again. So m stands for the first term times the last term, which is going to be 12. 1 times 12 is 12. A is the middle term, so that's negative 7. And we have to find two numbers that multiply to 12 and add up to negative 7. And so the numbers that I can think of that would do that are negative 4 and negative 3. So negative 4 times negative 3, a negative times a negative is positive, and negative 4 plus negative 3 is negative 7. So those are the two numbers. So this is equal to x squared minus 4x minus 3x, because the middle term splits, plus 12. And then I factor the first two and factor the last two. I just group the first two, group the last two. So there's nothing, well, there's really just x in common. So that's x minus 4. And what's in common over here? Well, I'm going to factor out the negative 3. And what's left? It's x minus 4. All right? And then we can factor this again. So we get x minus 4, x minus 3. And that's how you write this. So you write f of x is equal to that. And that's how you write that in factored form. Let's do E. E says we have to find the x-intercept. So remember, when we find the x-intercepts, we're basically setting y to 0. So we're going to set y to 0, so f of x to 0. And that is equal to x minus 4, x minus 3. And then each of these can be equal to 0. So x minus 4 equals 0. So x equals 4. That's one term. And then x minus 3 equals 0. So x equals 3. And that's the other x-intercept. So x equals 4 and x equals 3. Those are the intercepts that we have. Let's do F, where we have to find the vertex. So remember the equation, the x-coordinate of the vertex is equal to p plus q. It's halfway between the x-intercepts. So it's p plus q divided by 2. So it's 4 plus 3 divided by 2, so which is equal to 3.5. So we have the x-coordinate of the vertex. In order to find the y-coordinate of the vertex, all we have to do is take it and plug it into the equation. So our equation was x minus 4, x minus 3. And what we're going to do, instead of the x, we're going to plug in the x-coordinate of the vertex, which is 3.5. So it's going to equal to 3.5 minus 4 and 3.5 minus 3. So that's equal to negative 0.5 and 0.5. And that's equal to negative 0.25. So our vertex, the coordinate of our vertex is here's the x, here's the y. So v, so that's which stands for the vertex, is going to be 3.5, comma 0.25, and that's the coordinate of the vertex. Now, G says find the equation of the axis of symmetry. Well, the axis of symmetry will go through 3.5. So therefore, the equation of the axis of symmetry is x equals 3.5. Let's do H. Now, H basically says draw a sketch of it. So we have to use all the information that we've been given to help draw the sketch. Okay? So we know that our x-coordinates are 3 and 4. I'm not drawing it to scale here, but I just want to basically draw a rough sketch of how the parabola would look like. We know that our axis of symmetry will be halfway through this, right? So this is going to be x equals 3.5. So this is the sort of the dividing line for our parabola, for the symmetrical part. And we know the vertex is going to be at negative 0.25, right? And one other thing we know is that our y-intercept is going to be at 12. So using all these points, basically, using all these points, basically, we're going to sort of determine where this is going to be, which is, let me just draw that a little bit higher up. So it just makes it a little bit smoother when I draw it. Okay, so I'm going to connect all of these with a red line. So basically, I have these dots here. 1, 2, my vertex is right there. My other x-intercept is right there. So I'm just going to connect all of these with a red line. Okay, so it's not the smoothest graph, but basically you get the picture that here's the parabola right there. I'm sorry that I didn't really draw it as well as I should have, but anyways, you get the idea that that's basically our sketch. Finally, the last one is where we have where basically it says find the other for f of 2. So let me draw that. So 2 must be somewhere over here. So let's just say that's 2. So for 2, so find the other point that has the same output, right? So we do the same thing. So here's 2 and here's 3.5. So what is the distance between 2 and 3.5? Well, it's 1.5. And the other corresponding output, this is basically where D is, will also be 1.5 away. So it's 1.5 away. So what's the distance from 3.5, which is right here, and 1.5 away? Well, therefore, that has to be 5. So because 3.5 plus 1.5 is equal to 5. The reason how I got 1.5 is I know, well, basically we're trying to find the same sort of output as f of 2. And f of 2 is really 1.5 away from our axis of symmetry. So the corresponding point that will be symmetrical to f of 2 must also be 1.5 away. So 3.5 plus 1.5 will be 5, so therefore D is equal to 5. And that's the answer for I. All right, let's move on to the next one. Number 3. Number 3 is 21 plus x squared minus 10x. So 21 plus x squared minus 10x. Yeah, that's right. So let's do A. So A says rearrange it. So therefore f of x, if we rearrange it, remember, start with the highest degree, which is x squared, and then the second one, and in descending order, so minus 10x plus 21. So this is in standard form. B says find the vertical stretch. Well, the vertical stretch right here is the coefficient in front of the x squared, so it's 1. C says find the y-intercept. Well, it's always the constant in standard form, so it's 21. D, we have to factor this. We have to get this in factored form. So let me just go down here. So it's x squared minus 10x plus 21. So if we want to factor this, m will be the first term times the last term. So 1 times 21, which is 21. A is the middle term, which is negative 10. Okay? And we have to find two terms that multiply to 21 and add up to negative 10. So the two terms I can think of, the two numbers, are negative 7 and negative 3. Negative 7 times negative 3 is positive 21. Negative 7 plus negative 3 is negative 10. So what happens is that this middle term will split. So we get 1x squared, and it'll split into these two numbers right here. So it's minus 7x minus 3x plus 21. Then we group the first two, and we group the last two. So if we group the first two, the common term is x, and we basically have x minus 7. And if we group the last two, we take out the negative 3, and we get x minus 7. And the reason why it's minus 7 is because negative 3 times negative 7 is positive 21. We see that these two are the same, so we're on the right track. So it's x minus 7 and x minus 3. Fantastic. So that's basically the quadratic equation in factored form. Let's do E. E basically says find the x-intercepts. So if we want to find the x-intercepts, this is the original equation. X minus 7, x minus 3. Remember that f of x can also just be written as y, right? And if you want to find the x-intercept, it means where y equals 0. So this is 0. So x minus 7, x minus 3. And so we can set each of these to 0. So x minus 7 equals 0. So x equals 7. And then the second one, x minus 3 equals 0. So x equals 3. So these are our x-intercepts. F says to find the vertical, so the coordinate of the vertex. So the coordinate of the vertex will be halfway between the x-intercepts. So the x-coordinate is going to be, remember, p plus q divided by 2. P and q basically stand for the x-intercepts. So it's going to be 7 plus 3 divided by 2. So it's 10 divided by 2, which is 5. So the x coordinate of the vertex is 5. Now, in order to find the y coordinate, we just have to plug it back into the equation. So the equation was, or we can choose the factored form or the standard form, doesn't matter. I'm just using the factored form. So it's x minus 7, x minus 3. And I'm going to take this 5 and plug it in right here. So it's going to be 5 minus 7 and 5 minus 3. And that's going to be negative 2 and positive 2, which is negative 4. So the coordinate of the vertex, v stands for vertex in this case, coordinate of the vertex is going to be 5 and negative 4. And that's the coordinate of the vertex. All right, so we got F. Let's do G. G says find the axis of symmetry. Now the axis of symmetry is basically the x-coordinate of the vertex. Now it says the equation of the axis of symmetry. So it's going to be a vertical line, so we have to say x equals 5. So it's simply the equation of the axis of symmetry is always going to be the x-coordinate of the vertex, but make sure you write x equals 5. Don't just write 5, because we want the equation. And finally, okay, so H says sketch basically this whole thing. So let's do it. So here we have something like this, something like that. Now let's get the points. We have a one x-coordinate, x-intercept is 3. Another x-intercept is 7, right? We know the axis of symmetry is x equals 5, so it's going to go halfway through that, so it's going to be x equals 5. We know the y-coordinate of the vertex is going to be negative 4, so this is negative 4. And finally, the y-intercept that we've determined is 21, okay? And so what I'm going to do is I'm just going to draw these points in red, because we know that our parabola will go through these points. So finally, that's just what I'm going to sketch. I'm going to sketch it like that. It's obviously not the smoothest in the world, but you get the idea that this is the parabola that it's going through. Finally, let's do I. And I'm going to use the help of the diagram to help me determine what I is. Now, we want to find where f of d equals f of 2, right? So in other words, the output where x is equals to 2, we got to find the corresponding d that gives us the same output. So here is 2, and so here's the output, okay? So in order to find the corresponding output, which is somewhere over here, and this value is d, we have to take advantage of the axis of symmetry. So here's 2 and here's 5. So what's the distance between 2 over here and 5? Well, the distance is 3, is the distance of 3. So to find the corresponding output, because this is symmetric, because the output here must be equal there, this distance must also be 3. So if this is 5 and the corresponding output is 3 away, d has to be 5 plus 3, or in other words, d has to be 5 plus 3, or basically 8. Right? So the x-coordinate of that is 8, so therefore d is equal to 8. So that's what I is, and that's how we get the answer for number 3. Let's do number 4. Number 4. The original one was 11x minus x squared minus 28. So 11x minus x squared plus 28. So A said to rearrange it, so f of x is equal to negative x squared plus 11x plus 28. B says find, okay, so the vertical stretch here is actually 1. Remember, it's not negative 1. The negative deals with the reflection. So the vertical stretch is 1, but you should state reflected over the x-axis. Okay? So C says find the y-intercept. It's the constant in the standard form, so that's simply 28. D says rearrange, oh sorry, we want this in factored form. So here is the standard form, so plus 11x plus 28. So using the man method, remember it's the first term times the last term. So it's negative 1 times 28, which is negative 28. A is the added term, so that's the middle term always, so that's 11. So we got to find two numbers that multiply to negative 28 and add up to 11. So the two numbers that I'm thinking of, yes, so the two numbers that let me just think here, to add up to 11, so hold on one second. The two numbers that I'm thinking here should be, sorry, it should be, is that right? Sorry, I made a small mistake here. This is not, sorry, I made a mistake here. This is a negative 28, so that means the y-intercept is negative 28, and that means this here is also negative. I just wrote it wrong. So a negative 1 times negative 28 must be positive 28. So m is positive. So the numbers I'm thinking of are 7 and 4. So 7 times 4 is 28, and 7 plus 4 is 11. Yeah, sorry about that mistake. I just should have written it properly or just checked my work. But anyways, that's basically the equation. So anyways, so here's 7 and 4. So the middle term splits. So it's negative 1x squared plus 7x plus 4x minus 28. So then you want to group it. So you're going to factor out the negative 1. Sorry, no, you're not going to factor out just negative 1. You're going to factor out negative 1x. And what's left is x minus 7. And what you're going to factor out here is the 4. And what's left is, again, x minus 7. We see that the x minus 7, so we know we're on the right path. So it's going to be negative 1x plus 4 and x minus 7. Now, if you observe, one thing is that what we want is a x minus p, x minus q. So in other words, we want these x's to be positive. Now over here the x is positive, but over here it's not. So we must factor something out again. So what we're going to factor out in this case is the negative 1. So if we factor out negative 1 here, we get x minus 4. And it's going to be x minus 7. And this is the factored form, or the factored form that we are looking for. E. Now it says find the x-intercept. So basically y is equal to negative 1, x minus 4, x minus 7. And what we're going to do is, if you ever want to find the x-intercept, it means y is equal to 0. So it's negative 1, x minus 4, x minus 7. Now if you divide by negative 1, basically it's going to be 0 is equal to that. So that negative 1 really doesn't even matter. We can just compare each of these to 0. So it's going to be x minus 4 equals 0, so x equals 4. And then x minus 7 equals 0, so x equals 7. So these are our x-intercepts. Let's do f. F says to find the coordinate of the vertex. So let's first find the x-coordinate, which is p plus q divided by 2. Remember, p and q are simply the x-intercepts themselves. So it's going to be 4 plus 7 divided by 2. So that's 11 divided by 2, which is 5.5. Now if we want to find the y-coordinate, we simply take the x and plug it into the equation. So it's negative 1, x minus 4, x minus 7. And we're just going to take this 5.5 and plug it into each of these x's. So it's going to be negative 1, 5.5 minus 4, and 5.5 minus 7. Let me just scroll down here. So it's going to be negative 1, 5.5 minus 4 is 1.5, and 5.5 minus 7 is negative 1.5, and that is going to be positive 2.25. All right, so basically the coordinates of the vertex are 5.5, which is the x, and 2.25, which is the y, and that's basically the coordinate of the vertex. Now let me do h. So h says to sketch it. So if we're going to sketch it, what we're going to do is we're going to have that there and that there. So basically, one x-coordinate is 4. The other x coordinate is 7. We know our axis symmetry is halfway, so x is going to be 5.5. We know that basically the y coordinate of our vertex is 2.25. And finally, we also know that our y coordinate, or sorry, y-intercept is -28. So I'm just going to highlight the points that we know in red. Okay, and we're going to use this to sketch that. So that's basically a sketch of our graph. And finally, we're going to do I, which is we got to find f of d is equal to f of 2, which means, well, let's figure out where 2 is. So 2 is probably somewhere over here. So let's just say here's 2. So we got to find the equivalent output on the other side, right? So what's the distance between 2 and 5.5? Well, this distance between 2 and 5.5 is 3.5. So since this is a line of symmetry, the other corresponding equivalent point will also be 3.5 away. I got 3.5 from 5.5 minus 2, so that distance is 3.5. So the equivalent point must be 3.5 away. So 5.5 plus 3.5, so d is equal to 5.5 plus 3.5, which is equal to 9. So d is equal to 9, and that's the solution. So this point right here, d, which is basically 9. Okay. Let's move on to the next one. Let me just copy this one correctly. So, so number 5, what is it? So it's basically -4 minus x squared plus 4x. So A says to rearrange this. So f of x is equal to -x squared plus 4x minus 4. All right. So B. So B says to write down the vertical stretch. Oops. The vertical stretch is actually 1. It's not -1 because remember the negative tells us that's the reflection. So the vertical stretch is 1. So but we would say reflected across, oops, ACROSS, x axis. Right? C says to find the y-intercept, and the y-intercept is always constant in the standard form. So this is going to be -4. D is, so basically factor that. So it's -1x squared plus 4x minus 4. And so remember, we use the man method to do this. So it'll be negative. So it'll be the first term times the last term. So -1 times -4, which is 4. A, which is the middle term, which is also 4. And then you got to find two numbers that multiply to 4 and add to 4, and of course that's 2 and 2. So this middle term will split. So it's equal to -1x squared plus 2x plus 2x, because the 2 and 2, minus 4. You group the first two, and then you group the last two. So what's going to factor out is -1, -1x, and what's left is x minus 2. And then what's going to factor out here is 2, and again it's x minus 2. So it's going to be -1x plus 2, and what's left over is the x minus 2. So these x minus 2 basically comes here, and the -1x plus 2 is from here. Now remember that what we want is ax minus p x minus q. This is the form that we want, and we want our x's to be positive. So over here the x is positive, so that's fine, but here it's not. So what we want to do is factor that -1 out. So in order to factor that one out, put -1, x minus 2, and x minus 2. And that's how we factor it out. So this is the factored form. All right? So make sure you always make sure that the x's are positive, because that's what we desire. Sorry, and then the next one says find the x-intercepts. So that's E. So in order to find the x-intercepts, so y is equal to -1 x minus 2, x minus 2. So in order to find the x-intercepts, it's always when y is equal to 0. So negative 1, x minus 2, x minus 2. Oh, x minus 2. That's 2. Let me just clarify that, just to make sure there's no problems. So that's x minus 2. Now, when we're setting it to 0, if you divide by negative 1, it really doesn't matter because then what we can do is set each of these to 0. So basically it'll be x minus 2 equals 0 and x equals 2. And then again, for this one, we can do x minus 2 equals 0, which is x equals 2. So since they're both the same, there's really just one solution, which is x equals 2. And this is the final solution. There's only one intercept. All right? And we'll see what that means graphically in a second. Let me just get the white back. So let's do f. Now, f says to find the coordinates of the vertex. So if you recall, the equation was x equals p plus q divided by 2. And since we found that we have really two of them, which are exactly the same, it's really 2 plus 2 divided by 2, which is 4 divided by 2, and which is 2. So it's not really any surprise that the x-coordinate of the vertex is 2 because they're both the same. The average of the same number will be the same number. So we got the x-coordinate. Now we need the y-coordinate. So it's negative 1, x minus 2, x minus 2. All right. And what that means is we just have to take this value and plug it into the x's. So it's negative 1, 2 minus 2, 2 minus 2, which is negative 1 times 0, which is simply 0. So the vertex is really the x-coordinate here, which is 2, and the y-coordinate, which is 0. So that's the coordinates of the vertex, 2, 0. Now, G says find the equation of the axis of symmetry. If you have the vertex, it's straightforward. So the equation of the axis of symmetry is x equals 2. That's pretty much it. Now, H says to graph it. So let's graph it. Here's the graph. Here's the graph. We have let me just use green. So we have really just one x-intercept, which is 2. I mean, 2 and 2, really, it's just one of them. The other information that we have is that we have the y-intercept, which is negative 4, and that's, and also we know that the axis of symmetry is basically x equals 2. So if we graph this, and so the points that we really have are this and this, what's going to happen is that it's just pretty much going to look like this. It's going to come up there and come up there. So really, we just have one intercept, and it just touches the x-axis. So that's what it looks like. Now, I says f of d is equal to f of 2, right? So f of 2 is pretty much, it's right here. It's right on the vertex. And since this is the axis of symmetry, there cannot be any other d because it's right on the axis of symmetry. There's no other value that will give the same output. So therefore, d is actually equal to 2 because it's on the line of symmetry. It's on the line of symmetry. So d has to end up being the same number. Okay, so d in this case is 2 because it's just right on the line of symmetry. Okay, let's move on to the next one, which is number 6. Number 6. So number 6. Let me copy it correctly. So number 6 is 12 minus x squared minus x. So A is f of x is equal to negative x squared minus x plus 12. So that's how you rearrange it, and that's in standard form. B says write down the vertical stretch. So the number here is just 1. So the vertical stretch is really 1, but the negative tells us that it's reflected over the x-axis, right? And that's it. C says find the y-intercept, which is the constant, which is right there. So the y-intercept is 12. D says figure this out in factored form. So it's negative 1x squared minus x plus 12. So in order to factor, we use the man method. So it's -1 times 12, which is -12. The a term is always the middle term, and this is simply -1. So we got to find two numbers that multiply to -12 and add up to -1. And these two numbers are -4 and 3. -4 times 3 is -12. -4 plus 3 is -1. So what that means is that this middle term will split, right, into -4. So let's look at how that turns out. So it's -1x squared and splits to -4x plus 3x plus 12. And what we do is we group the first two and group the last two. So it's -1x, x minus, it's x plus 4, because -1x times +4 is -4x. And then if we factor this out, it's going to be 3x plus 4. And if now we see that it's -1x plus 3, and it's x plus 4. And remember that we want our factored form in this form, x minus p, x minus q. So where here your x and p's, so you want your x's to be positive. So we see that x is positive here, but not here. So we're going to have to change that. So we factor out the -1. We factor out the -1 here, so it's -1. We get x minus 3 and x plus 4. And that's our factored form. So a here is -1. Let's do the next part, which is e, find the x-intercepts. So really, y is equal to -1, x minus 3, x plus 4. Okay, so in order to find the x-intercept, that's when y is equal to 0. So 0 is equal to -1, x minus 3, x plus 4. Now, anytime it's set to 0, you can really just set the factors set to 0. So it's x minus 3 equals 0, so x equals 3. And then it's x plus 4 equals 0, so x equals -4. So these are the x-intercepts. F says find the find the coordinates for the vertex. So x equals p plus q over 2. Remember, p and q are the x-intercepts, so 3 and -4 respectively. So it's 3 plus -4 divided by 2, which is -1 divided by 2, which is -0.5. Now, if we want to find the y coordinate of the vertex, you just plug it into the equation. So the equation was -1 x minus 3 x plus 4. And what we're going to do is just plug in this -0.5 into each of these x's right here. So it's going to be -1 is -0.5 minus 3, and it's going to be -0.5 plus 4. And it's going to be, this is -3.5, and that's +3.5. And the answer to that is, give me 1 second. Oh yeah, it's basically 12.25, and that's +12.25. So the coordinates of the vertex are simply -0.5 for the x and 12.25 for the y, and we're done. Okay, so we got that, and finally, okay, so not finally, but G, find the equation of the axis of symmetry, and that's simply the x coordinate of the vertex, so x equals -0.5. H says to graph it. So let me do that right here. So one value is -4. The other value is 3. The axis of symmetry is -0.5. So it's going to be like that. So it's -0.5. And we have basically the y coordinate of the vertex is 12.25, but the y-intercept is at 12. So I'm going to use the red point basically to highlight all these points. So here's the vertex right there. Here's the y-intercept. Here's the other x-intercept. And now we're just going to connect these dots. So here's the vertex, the maximum point, and so just imagine that it sort of went through there. I know I didn't really do a good job of sketching that, but anyways, you get the idea of how the parabola looks like. Now, finally, I is where we have to figure out where f of d equals f of 2. So 2 would be somewhere over here, and so here's the output 2. So we want to find where the value of d, which is basically its sort of reflection across the axis of symmetry. So in other words, the corresponding point that will give us the same output. So here's d. So we got to find the value of d over here. So how do we do that? So here is, we need to figure out the distance from this point from 2 till the axis of symmetry. Well, the distance from 2 till the axis of symmetry is, if here's negative 0.5 and here's 2, this distance is 2.5. And so d will also be 2.5, a distance of 2.5 away from the axis of symmetry. But it's going to be more negative because it's further to the left of the axis of symmetry. So d is equal to the axis of symmetry, which is negative 0.5, and then we're moving 2.5 away from it. So it's negative 2.5. So negative 2.5 minus 2.5 is negative 3. So d is equal to negative 3. And that's basically how we get that value. Let's move on to the next one, which is number 7. So let's do number 7. So what was the original one? I'm just looking at my sheet over here. So the original one was simply x squared plus 3 plus 4x. Okay, so the first one said to rearrange it. So f of x is simply x squared plus 4x, remember in descending order of degree, plus 3. Okay, b said to find the vertical stretch. It's going to be the leading coefficient for x squared, so it's simply 1. C says to find the y-intercept. It's always the constant, so that's going to be 3. D says to figure this out in factored form. So it's 1x squared plus 4x plus 3. So if we use the man method, it's 1 times 3, so that's 3. A is always the middle term, which is 4. We've got to find two numbers that multiply to 3 and add up to 4. And these two numbers are simply 3 and 1. So it's going to be 1x squared, and this middle term splits. So plus 3x plus 1x plus 3. You group the first two, you group the last two. So what's common between these two? It's simply 1x, and then it's going to be x plus 3. What's common between these two? There's nothing really in common, so when there's nothing in common, you just simply say it's 1, because 1 is common with everything. So it's going to be x plus 3, and then you get x plus 1, and then you get x plus 3. I could have written 1x plus 1, but I mean, that's really just the same thing as saying x plus 1. So, oops, I don't know why that went away. So it's basically x plus 1, x plus 3, and this is the factored form. F of x is equal to that. Now, E says to find the x-intercepts, and basically we have y is equal to x plus 1, x plus 3. Now, if we want to find the x-intercepts, that's where y is equal to 0. So 0 is equal to x plus 1, x plus 3. And let me just scroll back up. So really, if I want to solve for x, it's really x plus 1 equals 0. So x equals negative 1. That's one solution. And x plus 3 equals 0. So x equals negative 3. That's the second solution. All right, perfect. So, oh yeah, and then the next part is part G. G says to find, oh no, sorry, part F. My apologies. We have to find the vertex. So the vertex, the x-coordinate of the vertex is x equals to p plus q divided by 2. So that's going to be negative 1 plus negative 3. Remember, p and q are the x-intercepts. So that's what they are over there. So it's negative 4 divided by 2, which is negative 2. To find the y-coordinate of the vertex, we simply, well, here's the equation, which was x plus 1, x plus 3. To find the y-coordinate, we simply take the x-coordinate, plug it in here, and then solve for y. So it's negative 2 plus 1, and negative 2 plus 3. And that's equal to negative 1, 2, 1, which is equal to negative 1. So our vertex is, the x-coordinate is negative 2, and the y-coordinate is negative 1, and that's basically the coordinates of the vertex. Let's move on to G. G says to find the equation of the axis of symmetry. The axis of symmetry pretty much goes through the x-coordinate of the vertex, so x equals negative 2. H says to graph it, so let's graph it. So it's going to be like that. Okay. Use green. So our x-intercepts are negative 3 and negative 1. We know our axis of symmetry is x equals negative 2. Our y-coordinate of the vertex is negative 1, and the y-intercept is 3. So let's basically plot these points at 1, 2, 3. I'm just put that in red. And so now all I'm going to do is I'm just going to connect this. Like that. So this is our parabola. This is a sketch of our parabola. Let's do I. So I, basically we want to find where f of d is equal to f of 2. So the output is, where is f of 2? So 2, oops, maybe I should have extended this. So let me, okay, so let me extend this a little bit further, that, and this a little bit further, like that. So f of 2 is somewhere here, so the output is right here. So the corresponding point where we have the same output would be over here. So we need to find the value of d, which is right here. So in order to do that, since we basically have to use the line of symmetry, so what is the distance between negative 2 and 2? Well, the distance between negative 2 and 2 is 4, right? The distance negative 2 and 2 is 4. So if we want to find d, d will be basically the distance of 4 away from the same axis of symmetry. So how do we get d? So, well, we use our axis of symmetry, which is negative 2, okay? And we know it's 4 to the left of the axis of symmetry, so it's going to be minus 4. So it's negative 2 minus 4, which is negative 6. So the answer for this one is d is equal to negative 6. So this value right here is negative 6. Let's move to the next one, which is, what is it? It's number 8. So let's do number 8. Okay, so number 8 is, it's pretty much already set up for us. So minus x minus 2. So A says rearrange it. Well, it's already rearranged for us. So x squared minus x minus 2. B says to find the vertical stretch, which is basically the coefficient in front of x squared. So the number in front of x squared is simply 1, so that's it. C says to find the y-intercept, which is the constant in the standard form. So the answer here is simply negative 2. D says to rearrange it into factored form. So it's going to be x squared minus x minus 2. We can use the man method, so it's the first term times the last term, so it's negative 2. 1 times negative 2 is negative 2. A is the middle term, which is negative 1. And we got to find two numbers that multiply to negative 2 and add up to negative 1. So the two numbers that I'm thinking of are negative 2 and 1, because negative 2 times 1 is negative 2, negative 2 plus 1 is negative 1. Okay, so then basically this middle term splits, so it's 1x squared minus 2x plus 1x minus 2. You can group the first two and group the last two. So, so if I factor this out, I simply get x minus 2. And since there's nothing really in common between 1x and negative 2, so when there's nothing in common, there's always one thing in common, which is simply 1. 1 is common with anything. So, and then it's x minus 2. So 1 times x is 1x, and 1 times negative 2 is negative 2. These two are the same, so we're on the right path. So it's x plus 1, and then x minus 2, and that's basically the factored form. Next thing is E, where we want to find what the x-intercepts are. So it's y is equal to x plus 1, x minus 2. So in order to find the x-intercept, that's where y is equal to 0. So x plus 1, x minus 2. And yeah, okay, perfect. So if we want to solve for x, it's simply x plus 1 equals 0. So x equals negative 1. And x minus 2, no, we take the second one, equal to 0, so x equals 2. So that's the values for the x-intercepts. Let's do f. F said to find the coordinates of the vertex. So remember, the x-coordinate is p plus q divided by 2. Remember, p and q are the x-intercepts themselves, so it's negative 1 plus 2 divided by 2. So that's equal to 1 over 2, which is simply equal to half. Now, if we want to find the y-coordinate of the vertex, y is equal to, what was it again? It was, yes, it was x plus 1 and x minus 2. So all we have to do is take this x-coordinate and plug it in over here in order to get the y-coordinate. So it's, in other words, it's 0.5 plus 1 and 0.5 minus 2. And this is going to give us 1.5. This is going to give us negative 1.5. And this is going to be negative 2.25. So our vertex is simply 0.5 and negative 2.25. Okay, that's our vertex. Now, G says to find the equation of the axis of symmetry. Remember, it's always equal to the x-coordinate of the vertex, so it's x equals 0.5. Now, H says to graph it, so let's graph it. Okay, so 0.5 would be, okay, well, our two x-intercepts are negative 2 and what was the other one? Oh, sorry, no, it wasn't negative 2, my mistake. Let me just go back here, what was it? Oh, it was negative 1 and 2. So, let me just erase that. So it's negative 1 and say 2 is around there. We know our axis of symmetry is x equals 0.5. We know that the y-coordinate of our vertex, I'm just going to extend this further, the y-coordinate of our vertex is negative 2.25. And we also know that our y-intercept is at negative 2, which is just above. So I'm going to use some red dots to basically map this out. So what I'm going to do is, here's our parabola, goes through all of these points and then like that. So it's not the smoothest curve, apologies for that, but that's basically gives you an idea of a sketch of our parabola. Let's do I. So I says basically where f of d is equal to f of 2. Well, our f of 2 is really this right there. It's actually one of our x-intercepts. So the corresponding point, well, actually, you can see pretty much the corresponding point is negative 1. So you can pretty much write down that the answer is negative 1. But let's use the axis of symmetry to sort of determine that. So if the output here should equal to the output here, what's the distance? We're going to use the axis of symmetry to help us out. So the distance from the axis of symmetry to 2 is, from 0.5 to 2, is 1.5. So to find the corresponding point, the symmetrical point on the other side, it should also be 1.5 away. And so D is equal to the axis of symmetry, which is 0.5, and it's 1.5 away, so it's to the left of it, so it's minus 1.5. And 0.5 minus 1.5 is negative 1, which is exactly what we expected right here. It's negative 1, so it has to be that. So we could have done it by inspection because we know they're both x-intercepts, or we could have used the axis of symmetry and the distance from that to determine where the other symmetrical point is. Okay, now let's move on to number 9. number 9. Let's do number 9. So number 9 is x minus x squared plus 2. So if we had to rearrange it, it would be f of x is equal to negative x squared plus x plus 2. So what is our vertical stretch? Our vertical stretch is not negative 1. Like I could have just put a 1 there. It's not negative 1. It's 1, but the negative tells us that there's a reflection over the x-axis. Okay, so this is something to remember. C is to find the y-intercept. That's always the constant, so that's 2. D says to basically turn this into factored form. So it's negative 1x squared plus x plus 2. Now, if we use the man method, so m is equal to the first term times the last term, so that's negative 2. A is the middle term, which is plus 1 over here. So you see x, it just means 1. So two numbers that get multiplied to negative 2 and add up to 1 are simply 2 and negative 1. So 2 times negative 1 is negative 2, and 2 plus negative 1 is 1. So this middle term will split, okay? So it's negative 1x squared plus 2x minus 1x plus 2. And if we group these, so what's going to come out is negative 1x, and it's going to be x minus 2. And we factor out negative 1, and it's going to be x minus 2. And we know we're on the right track because those two are similar. So it becomes negative 1x minus 1 and x minus 2. So the thing is, what we want is a x minus p, x minus q. So remember that we're looking for these x's to be 1x and to be positive. So here it's positive, but here it isn't. So we want to factor out that negative 1. So it's going to be negative 1 x plus 1 and x minus 2. And that's our factored form. The next part says to find the x-intercepts. So y is equal to negative 1 x plus 1 x minus 2. And remember, whenever we want to find the x-intercept, that means y is equal to 0. So it's x plus 1 x minus 2. And okay, so oh right, so then basically each of these can be set to 0. So it's x plus 1 is equal to 0. So x equals negative 1. Oops. X equals negative 1. So that's one solution. And then we can use the second one. So x minus 2 equals 0. So x equals 2. And that's our second solution. Okay. F says to find the coordinate of the vertex. So first let's find the x-coordinate, which is p plus q divided by 2. Remember, p and q are the x-intercepts themselves. So it's negative 1 plus 2 divided by 2, which is 1 over 2, which is 0.5. And if we want to find the y-coordinate, it's negative 1 x plus 1 x minus 2. And that's the factored form. And what we're going to do is just take this x value and plug it in here to find the y value. So it's negative 1, 0.5 plus 1, and 0.5 minus 2. So it's going to be negative 1, 1.5, and that's going to be negative 1.5, and that's going to be 2.25. That's going to be positive. Let me just make sure I'm on the right track. Yep, that's right. And so our vertex is going to be 0.5. That's the x-coordinate, and the y-coordinate is 2.25, and we're done. Now for G, says find the equation of the axis of symmetry. And the equation, it just pretty much is the x-coordinate. So we say x is equal to 0.5. Let's do H. Let's move on to H. So here's H where we have to sketch it. So we know it's going to be something like this. We know that one of our x-intercepts is at negative 1. The other one is at 2. We have the axis of symmetry, which is x equals 0.5. we have the y-coordinate of the vertex is at 2.25, and the y-intercept is at 2. So I'm just going to draw this all in red. Okay, so basically I'm just connect these points right there. Perfect. So that's our parabola right there. Now let's move on to I. So I basically says find the point where f of d is equal to f of 2. Now f of 2, if you observe, is right here, f of 2, because that's the x and the output is 0. So we need to find the corresponding point, which, if you observe, really should be the other x-intercept right there. But let's prove that. Okay. So we're going to use the axis symmetry to help us out there. So what is the distance from 2 till the axis symmetry? Well, the axis symmetry is 0.5, so 2 to minus 0.5, so that's basically 1.5. So the corresponding point on the other side must also be 1.5 away, right? So in other words, this point right here should be, if it's symmetric, like to this point, it should be 0.5 and then 1.5 away from the axis symmetry. So in other words, D, well, which is basically D right there, should be the axis symmetry, which is 0.5, and then minus 1.5 away, okay, which should be -1, which is exactly that. We have -1 right here, and so therefore we know where we have the right solution. Number 10. Let's just do number 10. Okay, so the original one, as written, was -x plus x squared minus 2x. So basically we have, if you want to rearrange it, f of x is equal to x squared minus 2x minus 8. B is find the vertical stretch. Well, that's just 1, so that's just 1. C is, it's the constant term, find the y-intercept. It's the constant term in the standard form, so it's minus 8. D is basically factored form. So it's 1x squared minus 2x minus 8. So using the man method, we take the first term times the last term. So that's 1 times -8, so it's -8. A is the middle term, so that's -2. And n is the two numbers that multiply to -8 and add up to -2. So the two numbers that do that are -4 and 2. -4 times 2 is -8. -4 times plus 2 is -2. So it's 1x squared minus 4x plus 2x minus 8. So you take the first two terms and the last two terms, and so if you factor this, we get x out, and it would be x minus 4, and then what's common here is 2, so it's x minus 4, and we know we're on the right track, so it's x plus 2 and x minus 4, and we're good to go. So that's the factored form. Let's do E, which says to find the x-intercept, so y is equal to x plus 2, x minus 4. So basically, whenever we find the x-intercept, that means y is equal to 0. So x plus 2, x minus 4. So in this case, x plus 2 equals 0. We can set each of these to 0. So x equals -2. And then in the second one, we can also set that to 0. So x minus 4 equals 0. So x equals 4. So these are our two intercepts, or x-intercepts. F, find the coordinate of the vertex. So the x-coordinate of the vertex is x is equal to p plus q divided by 2. Remember, p and q are the x-intercepts themselves. So it's -2 plus 4 divided by 2, which is equal to 2 over 2, which is equal to 1. So x is equal to 1, that's the x-coordinate of the vertex. So if we go back to the equation, we need to find the y-coordinate of the vertex, which is x plus 2, x minus 4. So in order to find y, we have to take the x-coordinate, which we found here, and plug them in right here, and then we can get the y-coordinate. So it's 1 plus 2, 1 minus 4, and that's equal to 3 times -3, so it's equal to -9. So our vertex is 1, -9. G says find the equation of the axis symmetry. Remember, that's always just the x-coordinate of the vertex, so x equals 1. H says to sketch it, so let's just sketch it. This was it's number 10. So we have, let's do this. So my x-intercepts are -2 and 4. So here's go. So here's -2. Here's 4. My axis of symmetry is 1. So remember, it's halfway through those two. So x equals 1. My y-coordinate of the vertex, which we've just determined, is it's the other way around. My y-coordinate is -9. So this is -9, and we've determined that my y-intercept is -8. So if I basically put these points in red, so here's the one x-intercept, here's the y-intercept, here's the vertex, and here's the other x-intercept. So I'm just going to plot these properly. So that's my parabola. And finally, let's do I. So where f of d is equal to f of 2. So basically, f of 2, if this is 1, f of 2 will probably be somewhere right here. So here's f of 2. So we need to find the corresponding point, which most likely will be here, but let's just double check. So it actually might end up being, well, we'll see what that is. So we want to find what d is. So in other words, d right here, so the x coordinate. So the way to do that is we have to use the axis of symmetry. So what is the distance between 2 and the axis of symmetry? Well, if the axis of symmetry is 1, and this point is 2, we're at a distance of 1. So the corresponding point, the corresponding symmetrical point, must be also 1 away from the axis of symmetry, but to the left of it. So in order to find it, we get the axis of symmetry, which is 1, and then we subtract 1 because we're going to the left. We've got to find d. So we subtract 1, so it's equal to 0. So d is equal to 0. And that's how we find the symmetrical point on the other side. Okay, let's move on to number 11. Number 11. So we have 2x plus 2x squared minus 4. So if we want to rearrange this, it's f of x is equal to 2x squared plus 2x minus 4. So that's the rearranged part. B says find the vertical stretch. Well, this time it'll be 2. C, find the y-intercept. It's always a constant in the standard form, so it's -4. D says to factor this. So let me just do that here. So it's 2x squared plus 2x minus 4. Using the man method, it's the first term times the last term, so it's -8. A is the middle term, which is 2. So we've got to find two numbers that multiply to -8 and add up to 2. Well, that's 4 and -2, because 4 times -2 is -8. 4 plus -2 is 2. So it's equal to 2x squared plus 4x minus 2x minus 4. Group the first two and group the last two. So you factor out the 2x, and what do we get? It's x plus 2. And then you factor out -2, and you also get x plus 2. Then we factor this out, so it's 2x minus 2, and that's x plus 2. Now remember, what we want is a x minus p, x minus q. This is the factored form, and we want these x's to be positive. So here x is positive here, and x is also positive here, but there's a 2 in front, so we have to factor that out. So let's do that. So that's equal to 2x minus 1, x plus 2, and this is the factored form. Okay, let's do E. E says to find the x-intercepts. So y is equal to x minus 1, x plus 2. If you want to find the x-intercepts, that just means that y is equal to 0. So x minus 1, x plus 2. If you divide by 2, you'll basically get 0 is equal to this. So you can really just set each of these to 0. So it'll be x minus 1 equals 0, so x equals 1. And then you do x plus 2 equals 0, so x equals negative 2. And that's the solution for the x-intercepts. F says to find the coordinates of the vertex. So x equals p plus q divided by 2. And remember, p and q are the x-intercepts themselves. So 1 plus negative 2 divided by 2. So it's equal to negative 1 divided by 2, which is equal to negative 0.5. So that's the x-coordinate of the vertex. The y-coordinate of the vertex is going to be 2, x minus 1, x plus 2. So all we have to do is take this x value and plug it in right here in order to get the y value. So it's 2, negative 0.5 minus 1, negative 0.5 plus 2. That's equal to 2, negative 1.5, positive 1.5. So that's going to be 2.5, so it's going to be negative 4.5, if I'm not mistaken. Let me just double check. Yes, that is correct. So our vertex is just going to be negative 0.5, which is the x-coordinate, and the y-coordinate, which we just found, is negative 4.5, and that's our solution. Okay, G is find the equation of the axis of symmetry. Well, that's right here. It's just the x-coordinate of the vertex, so x equals negative 0.5. H is the is sketch the graph. So we have our x-intercepts, which are, let me just draw them here. So we have negative 2 right here, and then we have 1 right here. We have our axis of symmetry, which is right here, which is negative x equals negative 0.5. And so the y-coordinate of the vertex is negative 4.5. And we know that our y-intercept is actually at negative 4. So if I just draw these points in red, so here's the x-intercept, here's the vertex, which goes to the axis of symmetry. Here's the y-intercept, and here's the other x-intercept. So it goes like that. And there's our parabola. Okay, here's I. So now I says find f of d is equal to f of 2. So f of 2 should be, so let's say here's 2. So the corresponding output must be somewhere on this side, and that's d. So how do we find that? So that's where we have to use the axis of symmetry, because the corresponding point will be the equivalent distance away from the axis of symmetry. So, didn't draw that right, so let me draw this again. So this distance here, from negative 0.5 to 2, the distance there is 2.5. So there's a distance of 2.5 from negative 0.5 to 2. So we got to find the corresponding distance from negative half to whatever point. So d is really just the axis of symmetry, which is negative 0.5, and it's going to be 2.5 to the left, so which means minus 2.5, so it's equal to negative 3. So that's the answer for d. So d is equal to negative 3. Okay, let's move to the next one, which is 12. So the original one that I wrote for 12 is 14x minus 2x squared minus 24. So so rearranging it is f of x is equal to negative 2x squared plus 14x minus 24. So that's the original rearrangement. Now B says find the vertical stretch. The vertical stretch is not negative 2, it's simply 2, but the negative tells us that there's a reflection across the x-axis. Okay. C says find the y-intercept. That's just a constant in the standard form, so it's simply negative 24. D says find the factored form, so it's negative 2x squared plus 14x minus 24. So let's, using the man method, it's negative 2 times negative 24, which is 48. A is the middle term, which is 14. So we have to find two numbers that multiply to 48 and basically add up to 14. So I'm thinking of, well, what two numbers would multiply to 48 and add up to 14? Well, 7 and 7 don't work. And 7 times... right, so the two numbers would be 6 and 8, because 6 times 8 is 48, and 6 plus 8 is equal to 14. So that means this middle term splits, and it'll be split into 6 and 8. So it's negative 2x squared plus 6x plus 8x minus 24. You group the first two and group the last two. So it's negative 2x, and then it's going to be x minus 3, because negative 2x times negative 3 is positive 6x. And then you can factor out the 8, and this also becomes x minus 3. So you get negative 2x plus 8 and x minus 3. And okay, so you might think that we might stop here, but you have to remember that our factored form is ax minus p x minus q. So that means we have a single x here and a single positive x over here. So this is fine, but we don't have a single positive x here. So we need to factor out that negative 2. So you factor out that negative 2 and you get x minus 4 and then x minus 3. And this is the factored form. Okay, so let's do the next part, which is E, find the x-intercepts. So we get y is equal to negative 2, x minus 4, x minus 3. So if you ever want to find the x-intercept, that just means where y is equal to 0. So it's negative 2, x minus 4, x minus 3. Okay, so what that means is you don't have to worry about this negative 2 because you can divide out the negative 2 and it'll still be 0 equals these two terms. So we can just set each of these to 0. So x minus 4 equals 0. So x equals to 4. And then x minus 3 equals 0. So x equals to 3. So these are our x-intercepts. F is find the coordinates of the vertex. So remember, the coordinates of the vertex will be halfway between these two. So x equals p plus q divided by 2. P and q are these x-intercepts right here. So 4 plus 3 divided by 2, which is 7 divided by 2, which is 3.5. The y-coordinate will be, it's simply x minus 4, x minus 3, and this is negative 2. Is that negative 2? I'm pretty sure it was negative 2. Yes, it was negative 2. It was negative 2. So what we have to do now is just take our x-coordinate and plug it in right here. So it's negative 2, 3.5 minus 4, and it's 3.5 minus 3. So that's equal to negative 2, and that's going to be negative 0.5, and this is going to be positive 0.5. So that's going to be a quarter times, so that's going to be 0.5. So our vertex is going to be, the x-coordinate of our vertex is 3.5, but the y-coordinate is 0.5. And so now, okay, let's go to G. G says find the equation of the axis of symmetry. That's just simply the x-coordinate of the vertex. So x equals 3.5. Make sure you always write x equals for the axis of symmetry, for the equation of the axis of symmetry. H. Now let's just graph it. So we have that and that. Okay. So anyways, we have one intercept, x-intercept, which is 3, another one which is 4. We know that the equation of the axis of symmetry is 3.5. The y-coordinate, as we've determined, is for the vertex is 0.5. And we also have determined from before, this is obviously not going to be the scale, that it's negative 24. So really what we're doing here is, here's the y-intercept, here's one x-intercept, here's the vertex, and here's another vertex. So if we connect the dots, That's our parabola. Now, let's do I, where I is f of d is equal to f of 2. So f of 2, so here's 2. Oh, let me just use yellow. Here's 2, and f of 2 is right there. So that's the y coordinate. So we want to find, basically what we want is we want the symmetrical point, which is right there. So on the same line. So this is d. So in order to find that, we have to find the distance to the axis of symmetry, because the corresponding symmetrical point will be the exact sort of same distance from the axis of symmetry. So what's the distance between 2 and 3.5, which is 1.5? And so the same distance to the other side will also be 1.5. So how do we find d? It's going to be 3.5, because that's the axis of symmetry. And it's going to be 1.5 to the right of it. So that's going to be plus 1.5. And so that's equal to 5. And so d is equal to 5, and that's our answer. Let's move on to number 13. So we only have 3 more left. It's exciting, exciting. Number 13. So let's do that. Number 13, the original one was 6 minus 3x squared minus 3x. So f of x is equal to minus 3x squared minus 3x plus 6. So that's the rearranged form. B says to find the vertical stretch. You might be tempted to think that it's negative 3, but no, it's 3. And the negative just means a reflection. So it's a reflection across the x-axis. C is the constant term. So the constant term, oh, sorry, it's the y-intercept, which is the constant term in the standard form. So it's 6. D is equal to, oh, sorry, we have to factor this. So it's minus 3x squared minus 3x plus 6. So if we want to factor this, we use the man method. So m is equal to the first term times the last term, so it's negative 18. A is the middle term, which is negative 3. So we're going to find 2 numbers that multiply to negative 18 and add up to negative 3. So the 2 numbers will be negative 6 and positive 3, because negative 6 times 3 is negative 18, negative 6 plus 3 is negative 3. So remember, the middle term splits, okay, into negative 6 and 3. So it's minus 3x squared minus 6x plus 3x plus 6. So we group the first 2 and we group the last 2. So it's minus 3x, and it's going to be x plus 2. And then we factor this out, so it's going to be 3x plus 2. And so we have minus 3x plus 3, and it's going to be x plus 2. So remember, what we want to do is, this is our factored form right here. So we want basically the x's to be positive and have a 1 as the coefficient. So this is fine, but this is not, because we have a negative 3 in front. So we have to factor out the negative 3. So what we do here is we factor out the negative 3 for this one, and what we're left with is going to be x minus 1 and x plus 2, because negative 3 times negative 1 is positive 3. So this is the factored form. And now we have to find the x-intercepts. So y is equal to negative 3, x minus 1, x plus 2. And whenever you're finding the x-intercepts, that just means y is equal to 0. So negative 3, x minus 1, x plus 2. And you can divide out the negative 3. So what that just means is 0 is simply equal to each of these. So you don't really even have to worry about the negative 3. So x minus 1 equals 0. So x equals 1. So that's one solution. And then x plus 2 for the second one is equal to 0. So x equals negative 2. So we got E done. Let's do F. So let's find the, F says to find the coordinate of the vertex. So it's equal to x equals p plus q divided by 2. So we take 1. So these are our x-intercepts, plus negative 2 divided by 2. So it's negative 1 over 2, which is negative 0.5. For the y coordinate, let's just go back to the equation as negative 3. So it was negative 3, x minus 1, x plus 2. And so all we have to do in order to find the y coordinate is you take the x coordinate of the vertex and plug it in right here into these x's right here. So it's going to be negative 3, negative 0.5 minus 1, and it's going to be negative 0.5 plus 2. So it's going to be negative 3, this is negative 1.5, this is 1.5, and that's going to be positive 2.25, so it's going to be 6.75. So 6.75 for number 13. Yeah, so our vertex, basically, this is our what we want, is negative 0.5 for the x and 6.75 for the y, and that's our solution. Okay, G is find the equation of the axis of symmetry. The axis of symmetry goes through the x coordinate of the vertex, so really it's just x equals negative 0.5. H is, so let's just sketch the graph. Okay, so we have one x-intercept right here, which is negative 2. Another one, which is right here, which is 1. We have our axis of symmetry, which is x equals negative 0.5. Our vertex goes through the axis of symmetry and has a y coordinate of 6.75. Our basically y-intercept is 6. So so let's just color that. So that's one x-intercept. Here's our vertex. Here's the y-intercept, and here's the other vertex. And then if I sketch that, basically that's my beautiful parabola right there. Okay. Actually, what I'm going to do is I'm just going to oops. I'm going to stretch this a little bit longer. Okay. All right. So now let's go to I. I says find f of d is equal to f of 2. So f of 2 is, so let's say here is 2. So here's f of 2. So the corresponding point has to be somewhere over here. It has to be on like the same line. It's over there. So here's d. Okay. So how do we find d? Well, remember, it's going to be, if it's going to be the symmetrical point across the axis of symmetry. So first we need to find the distance to the axis of symmetry. So what's the distance from negative 0.5 to 2? Well, the distance from here to here is 2.5. And so the symmetrical point has to be also the same distance away on the other side, which is also 2.5. So let's figure out what d is. So if d, this point d, is basically the same distance away from the axis of symmetry, so the axis of symmetry is negative 0.5, and it's going to be 2.5 to the left, so it's minus 2.5, and that's equal to negative 3, and that's basically our answer. All right, number 14, last two problems, so let's do this. Number 14. So the original one was, oh, okay, it was actually fine. 2x squared minus 4x minus 6. And the rearranged form is, we don't even have to rearrange it. It's exactly the same. So minus 4x minus 6. B. What's the vertical stretch? Well, that's the coefficient in front of x squared, so that's 2. C. It's going to be the constant term in the standard form, so that's minus 6. So the y-intercept is minus 6. D is factor this, so it's 2x squared minus 4x minus 6. Now if we want to factor it, we can use the man method. So so m stands for the first term times the last term, so it's negative 12. A stands for the middle term, which is negative 4. And n is find two numbers that multiply to negative 12 and add up to negative 4, and that's going to be negative 6 and 2, because negative 6 times 2 is negative 12, negative 6 plus 2 is negative 4. So what that means is that this middle term splits into negative 6 and 2. So it's 2x squared minus 6x plus 2x minus 6. So let's basically factor this out. So it's 2x, x minus 3 plus 2, x minus 3. and this ends up being 2x plus 2 and x minus 3. Remember that our factored form is a x minus p x minus q, which means that the x's have to be positive and they just need a coefficient of 1. So this is fine because it has a coefficient of 1, but this doesn't because it has a coefficient of 2. So we have to factor out that 2. So what happens is this is 2x plus 1 and x minus 3. We factored out the 2, and so we get 2 times x plus 1. So this is our factored form. The next one is E, where we have to find the x-intercepts. So y is basically equal to this factored form 2, x plus 1, x minus 3. And so, oops, no, I'm just gonna, so when we want to find the x-intercepts, that just means y is equal to 0. So 2, x plus 1, x minus 3. Okay, so you can just divide out by 2. So 0 just really equals to each of these factors. So x plus 1 equals 0. So x equals negative 1. Oops. So x equals negative 1. And x minus 3 equals 0. So x equals 3. And so those, I think I should just make this a little bit clear. So that's equal to 3. So these are our x-intercepts. F. Find the coordinates of the vertex. So the x-coordinate of the vertex, it's going to be halfway these x-intercepts. So remember, it's p plus q divided by 2. P and q are just the x-intercepts themselves. So negative 1 plus 3 divided by 2. So it's equal to 2 over 2, which is equal to 1. So that's the x-coordinate of the vertex. Now we've got to find the y. The y-coordinate of the vertex is going to be, well, here's the equation, x plus 1, x minus 3. And what we have to do is basically just take this x-coordinate and plug it in right here. So it's equal to 2, 1 plus 1, and 1 minus 3. So it's equal to 2 times negative 2, which is equal to negative 8. So our vertex is 1 comma negative 8. So that's our vertex. G says find the equation of the axis of symmetry. That's going to be the x-coordinate of the vertex. So simply x equals 1 right there. H says to sketch it. So let's sketch it. So we have, here's my horrible xy, not very straight, but it's okay. It'll do for now because I'm just doing a sketch. Here's negative 1. That's one of my x-intercepts. I have another x-intercept here. My axis of symmetry is x equals 1. My vertex is going to lie on that axis of symmetry, and we've determined that the y-coordinate is negative 8. We also know that our y-intercept is negative 6. So using a red dot, let me just plot. So here's one x-intercept right here, which is negative 1. This is the y-intercept, which is negative 6. This is the vertex right here, and here's the other. Here's the other x. I'm just going to erase that little line that I have there. I don't know why that just came out. So next, you just connect the dots. So you get that basically. So there you go. And so that's basically our graph. Finally, we want f of d is equal to f of 2. So f of 2, so here's 2, it's going to be right here. So the corresponding point, I'm assuming, will be somewhere right here. And let's just say that. So we need to find what d is, which is the x-coordinate right here. So how do we do that? We can pretty much see that it's going to be 0, but let's just determine that for sure. So remember, if we want to find the symmetrical point, it has to be the same distance away from the axis of symmetry. Our axis of symmetry is 1. This point is 2, so the distance between 1 and 2 is 1. So the other point right there has to be also a distance away from 1, a distance of 1. So D is going to be our axis of symmetry, which is 1, and it's going to be to the left of 1, like left by a distance of 1. So it's going to be 1 minus 1, so it's going to be 0. So this value here is 0, as we've pretty much determined before, so D is equal to 0. So in other words, f of 0 is equal to f of 2. Finally, let's get to our very, very last one. which is number 15. And it was 12 minus 3x squared. So let's rearrange it. So this is f of x is equal to minus 3x squared plus 12. Now, we only see 2 terms instead of 3, but that's fine. We just want a descending order, and this is okay. So let's do b. b says find the vertical stretch. It's not negative 3. It's simply 3, and it's reflected across the x-axis, right? C says to find the y-intercept, and that's going to be -12, the constant in the standard form, so it's 12. D says to factor it. So let's factor this. So we have 3x squared, negative 3x squared plus 12. So normally we're used to 3 terms. So what happens when we see 2? Well, really what that means is the middle term is just plus 0x, because 0 times x is simply 0, and we don't have to write that, plus 12. Now let's factor it using the man method. So it's the first term times the last term. So negative 3 times 12, so that's negative 36. A is the middle term, which is 0. So we've got to find 2 numbers that multiply to negative 36 and add up to 0. They're going to be negative 6 and 6. What that means is the middle term splits. So negative 3x squared minus 6x plus 6x plus 12. And then we factor the first 2 and the last 2. So it's going to be minus 3x. So it's going to be x plus 2. And then we factor out the 6, so it's going to be x plus 2. And this is going to be negative 3x plus 6. This is going to be x plus 2. Remember that our factored form is ax minus p, x minus q, where we want basically the x's to be positive and single, like a single 1x. So this is fine, but this is not. So we have to factor out the negative 3 from this term. So let's do that. So if I factor out negative 3, I get x minus 2, and, oh, sorry, I should get, yeah, x minus 2, and then x plus 2. So this is my factored form right here. The next part says to find the x-intercept, so really y is equal to negative 3, x minus 2, x plus 2. And if you want to find the x-intercepts, that just means where y is equal to 0, x minus 2, x plus 2. And you can divide out the negative 3, so really 0 is just equal to each of these factors. So what happens next is x minus 2 equals 0, so x equals 2. That's one solution. And we do the second one, x plus 2 is equal to 0, so x equals negative 2, and that's the second solution. F, find the coordinates of the vertex. So let's do that. So remember, the coordinates of the vertex, it's going to be halfway between the x-intercepts. So x equals p plus q divided by 2. So it's going to be 2 plus negative 2 divided by 2, which is 0 divided by 2, which is 0. Our equation is negative 3 x plus 2, x minus 2. And if you want to find the y-coordinate of the vertex, you simply take the x-coordinate, plug it in here, and then solve for it. So it's minus 3, 0 plus 2, 0 minus 2, which is equal to negative 3. This is a 0, not a 6. So it's 2, negative 2, and that's going to be 12. So our vertex is the x-coordinate of 0 and a y-coordinate of 12, and that's our equation. G says find the equation of the axis of symmetry. And that's simply the point where it goes to the x-coordinate of the vertex. So really, it's just x equals 0. Make sure you always write x equals 0 for the equation of the axis of symmetry. H is finally to sketch it. So let's just sketch it. Right? We have an x-intercept at negative 2, another at 2. Our axis of symmetry is x equals 0. So it goes right through the y-axis. This is x equals 0. The vertex basically is right at the axis of symmetry, which is 12. Okay? And that also happens to be our y-intercept. So basically, I just draw these 3 points right here, and I just connect the dots. And that's basically our parabola. Finally, let's do the last one, which is I. So we've got to find f of d is equal to f of 2. Well, f of 2 is pretty much right here. It's one of our x-intercepts. So we can pretty much tell, since the axis symmetry is 0, that this other symmetrical point has to be -2. But let's just determine that algebraically. So really, the best way to determine it is the axis of symmetry is going to reflect that point. So it's going to be the same distance. So what's the distance from 0 to 2? Well, that's 2. So the symmetrical point has to be a distance of 2 away, but to the left of it. So this is also distance of 2. So d, because this value is d, is equal to the axis of symmetry, which is 0, and it's going to be 2 away, 2 to the left of it. So it's -2, so it's equal to -2, which is correct because that was -2. And that's our solution. All right, so that's basically the solution for this problem set, and I'll see you for the next video, and I'll also see you for the next class. Bye.